Hey guys, I wanted to give you an example problem for the ninth graders who are doing the algebra review on complex fractions. I know you did it last year with Mrs. Surface, but it's been a while, so I just wanted to do one problem with you just to help out on your algebra review for this week. You can find videos on complex fractions on the internet, but most of them either are too easy or too hard. There's none that are really in this range right here. So this is what the problems on the algebra review look like. So I thought we would take a look at this one. This, I would say, is one of the harder ones. Some of the ones towards the beginning are a little bit easier. But the first thing that I want you to do is recognize that when you read this, 4x minus 12 over x squared plus 6x plus 8 all over x cubed minus 3x squared over x to the fourth plus 11x cubed plus 28x squared. Remember, we say all over right here. This is actually division right here. Okay, in fact, all of these horizontal lines are division. But this one in particular separates the top fraction that's in the numerator with the one that's in the denominator. So just as we would have, say something like 2/3 is the same thing as 2 divided by 3. When we do this right here, we can write it as horizontal division. And so this would be 4x minus 12 over x squared plus 6x plus 8 divided by x cubed minus 3x squared over x to the fourth plus 11x cubed plus 28x squared. Right, so we take the vertical division like this, that's the complex fraction, and write it as horizontal division. Okay, and then there's two different paths you could take here because there's two different things that need to happen. One is we need to factor all the numerators and denominators because we're going to be able to cancel things out. And the other is that we need to use keep, change, flip. We'll keep the first fraction the same. We'll change the sign from divide to multiply. We'll flip the second fraction. It does not matter which order you do those things in. So I'm going to choose to do keep, change, flip first and then factor, but you could do it the other way and it would be just the same. All right, so when we do keep, change, flip, we've got 4x minus 12 over x squared plus 6x plus 8 times x to the fourth plus 11x cubed plus 28 x squared over x cubed minus 3x squared. All right, now that we have this, I'm just going to factor everything. And in fact, at this point, I really shouldn't even need to go on because once you change it from this to this, we've already done algebra review problems that were written like this. We've done algebra review problems that were written like this, where we're multiplying rational expressions. But I'm going to keep going just so that you can see the whole process. All right, so I'm going to factor the 4x minus 12. That just is GCF factoring. So I'm going to take out a 4 and I get x minus 3. And then in the denominator, I need to factor x squared plus 6x plus 8. That is an easy trinomial. Trinomial, obviously, because it has 3 terms. Easy because the leading coefficient is 1. So when we factor like that, we split it into 2 parentheses. I put an x and an x here. And then I'm looking for 2 things that multiply to 8 that add to 6. All right, so that would be positive 4 and positive 2. And then in the second one, in each of these, I can take out a GCF first, and I definitely want to do that. This one is not an easy trinomial as it is. It does have the 3 terms and the leading coefficient of 1. Up here comes our friend again. Come on, you man. Okay, but it does not follow, technically it's called an easy general trinomial. The pattern here for the general part is that this has to be even, this has to be half as big, and this has to have no variable at all. So it doesn't fit that pattern. So we need to take out that common factor of x squared first. And when we do that, we get x squared plus 11x plus 28. That is now an easy general trinomial. Easy because the leading coefficient is 1. General because it has that pattern with the exponents. Even, half as big, nothing. And then it's a trinomial. All right, same thing in the denominator. This is just GCF. It's not a trinomial, so it's not easy trinomial or harder trinomial. It doesn't have 4 terms, so it's not grouping. It's not a difference of squares because 3 is not a perfect square and x cubed is not a perfect square. So we're just going to take out that x squared. And what we'll be left with is x minus 3. All right, so factored, 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 not yet factored. We still have to factor this part. So I'm just going to write everything over again. 4 times x minus 3 over x plus 4, x plus 2 times x squared. And then this will factor x and x. I'm looking for two things that multiply to 28 that add to 11. So that would be plus 7 plus 4. And then we've got x squared, x minus 3. All right, now we just go crazy with the canceling. We find out anything that they have in common that we can get rid of. So x minus 3, x minus 3, x plus 4, x plus 4, x squared, and then that's it. 4 doesn't cancel with anything, x plus 2 doesn't cancel with anything, and x plus 7 doesn't cancel with anything. So the final answer would be 4 times x plus 7 over x plus 2. And I would prefer if you would leave it factored like that instead of distributing the 4. Again, your job is to kind of prove to whoever is looking at this that you've factored it completely. So when it's in completely factored form and they can see that there are no common factors, then their job is easy to see that, yes, you've completely simplified. All right, so that would be your final answer. All right, hope that's helpful, but if not, please shoot me an email and let me know what else I can do. I can make up another problem and we can talk through it, but hopefully this helps. Thanks, bye.